My name is Tori, and this is the first video to the science portion of the S.A.T club. This one was on seasons. A big part of seasons are solstices and equinoxes. This one here is the spring equinox, which happens on March 21st. This one here is the summer solstice, which happens on June 21st of each year. This one up here is the fall equinox, which happens on September 22nd each year. And this one over here is the winter equinox, which happens on December 21st each year. An equinox is when the day and the night length are equal, which would be 12 hours each. And a solstice is when the sun is its highest point in the sky, or the lowest point in the sky for the northern hemisphere.
Hi, I'm Danny, and here we have the equinoxes and solstices, and Tori already labeled all of them. And so over here, the summer solstice, that's a weird arrow. On the summer solstice, we did all of the solstices for the northern hemisphere. So for the summer solstice, if this was the equator right here, then the sun's rays are hitting it directly, and the day is the longest in the northern hemisphere and the shortest in the southern hemisphere. And that's because the southern hemisphere gets less direct sunlight. And so now for the fall equinox, up there, how equinoxes work, the days and nights are generally the same amount of time. Usually they're about 12 hours each. And so that's where they get the equal in the equinox. And so that's why they're actually named equinox. And so for equinoxes, they happen only when Earth's axis is not tilted neither directly at the sun or away from the sun. And so this way, it's kind of sideways compared to the sun. So both hemispheres have the same amount of daylight hours. And now for the winter solstice, it's basically the same as the summer solstice, except backwards. The southern hemisphere will get more direct sunlight, and the northern hemisphere will get less direct sunlight. And so it's the shortest day in the northern hemisphere and the longest day in the southern hemisphere. And now I'm going to give it to Ben so he can do the next part.
Hi, this is Ben, and I'm going to be doing a little diagram here. And so we have the summer solstice for the northern hemisphere, which is up here. So with the summer solstice, it is also the winter solstice in the southern hemisphere. So there is much more direct sunlight on the summer solstice for the northern hemisphere. In the northern hemisphere, like right along here, there would be a lot more direct sunlight, which would heat it up a lot more in the same amount of area as down here, where there's a lot of indirect sunlight. So basically, the northern hemisphere, which is up here, they get much more direct sunlight on their summer solstice than the southern hemisphere gets on their summer solstice. Well, our summer solstice, which is their winter solstice. So that is really sort of a little diagram of it.
Hi, this is Danny again, and this diagram is basically exactly what Ben just showed, but from a perspective if you were on Earth. Now, the one that's over here, oh, that's in black. Oops. The one that's over here is for the northern hemisphere during a summer solstice for the northern hemisphere, and this is a southern hemisphere at the same time. And so what you can see here is the sun's rays are coming in at an area right here and going directly down and hitting a smaller area down on the northern hemisphere than on the southern hemisphere, where it's hitting a much larger area with the same amount of sunlight. And that's an example of direct and indirect sunlight. Indirect sunlight it like spreads out the sunlight across a larger area, because as you can see down here, that's a lot smaller than right here for the same amount of sunlight. So that's why it's colder during the winter than it is during the summer. And so this has been the seasons for
This has been the first science video to the S.A.T. club on seasons. Thank